Hey guys, I hope you're doing well. This is Ms. Hoffman. I wanted to take a couple minutes to review Empirical Formula. Both classes, Mr. Shepard's and mine, learned about Empirical Formula before we left with this craziness. I hope you all are doing okay. Please reach out and let us know if there's anything any of you need, and we can use our resources to help you out, whether it's family, food, school, questions about registration, any of that, and we can definitely point you in the right direction. So let's take a couple minutes to review empirical formulas, and then we'll have you do a couple practice problems on your own, and then we'll move on to doing molecular formula, which is pretty simple. It's just an extension of empirical formulas. So if you remember, empirical formula is your simplest formula. So if a pharmaceutical company has a drug and they want to make a generic form of the drug, they can do analysis and figure out how much of each element is in the compound, and then do a little bit of math and figure out what the actual formula is for the compound. And so that's the point of doing empirical formula. It gives you the simplest form, but it doesn't always, it's not going to give you initially your molecular formula, which we'll talk about in the next video. So your problem is going to look like the one that's on the screen right now. If it's in percents, remember that's going to be out of 100 or 100 grams, because percent is out of 100. And so we need to look at each element. So in this one, there's 4 elements. So we'll look at each one and then set it up in dimensional analysis. Remember, dimensional analysis, whatever's on top goes on the bottom of your next fraction. So if we have grams of calcium up here, it's going to go grams of calcium at the bottom of your next fraction. And we're going and converting to moles. So for our first problem, we have 24.7% of calcium, and we need to convert that to moles because we're looking for a mole ratio. That's all formula is. So 24.7 grams of calcium, we just need to convert that to a mole. That 40.8 grams comes from your periodic table, so make sure you're using that and you have that out every day when we're going through videos. That will help you a lot over the next couple of weeks. And then that gives us the 0.61627 moles of calcium. To start out with, that's all you need to find for each one of your elements. You don't need to go through and do the divide part yet because you don't know what to divide by yet. So once you do that for calcium, you're going to do the same thing for all your other elements. Make sure that when you divide, like for hydrogen down here, we're dividing by the 1.01 grams of hydrogen. Again, that comes from your periodic table. Don't use 40.08 when we're talking about hydrogen or carbon or oxygen. You need to use the actual atomic mass that is from your periodic table. That is the one with the decimals. We're not talking about the rounded number. So atomic mass is the one with the decimals. So I want you to look over this one and make sure that you understand where these numbers are coming from. Your first numbers are coming from the actual problem. Your masses, again, are coming from the periodic table. You use your calculator, divide, and you get these top numbers. Like for carbon, you got 1.2323 moles of carbon. And then the oxygen is over here. There just wasn't quite enough room. All right, so when you find these, your next step, step 2, is to divide by your lowest ratio. In this problem, your lowest ratio was calcium, the 0.61627. So we divide each of the mole amounts by your lowest ratio. And that gives calcium as 1. And then the rest of these, this is 1.9. Okay, that's roughly 2. Most of yours will probably be closer to like 1.98 if it's going to be about 2. It all has to do with sig figs. If you look over here, your 1.2 grams of hydrogen, that's not a lot of sig figs. If they had included more significant digits in their data, it would be closer to the 2 and not the 1.9. So we get 2 for carbon also, and then for oxygen, we get roughly 6. So when we put that ratio together, those numbers are just your ratios, your subscripts that are going to go at the bottom in your chemical formula. So we have calcium and hydrogen, 2 carbons and 6 oxygens. That kind of looks funny. For this one, you can actually change the formula a little bit. If I can get this to scroll down. I can't find, oh, there we go. That's not what I want to do, but that'll work. Down here in the bottom right corner, you might recognize HCO3. That would be from page 7 of your periodic table, your polyatomic ions. It's actually a polyatomic ion. It's imperative that you be able to recognize your polyatomics. Maybe look and see if you've got more than 3 elements, then you probably have a polyatomic ion in there, unless it's a combustion with an oxygen. So here you do have a polyatomic ion. So it's calcium and then your polyatomic ion, and there's 2 of them. So your 2 down here, that subscript, would apply to your hydrogen, your carbon, and your oxygen. So we would have 2 hydrogens, which you can see in your formula up here that you had 2. You'd also have 2 carbons, which is up here, and 2 times 3 is 6 oxygens. So that's the first problem. I want to scroll down, if I can get my computer to scroll. There we go. Okay. To this next problem, number 2. And I want you to press pause on the video, and I want you to take out a piece of paper and actually work through this problem and see what you get. When you get done, you can turn the video back on and see the answer key. So press pause so you can work through number 2. So here's the answer for number 2. So press pause right quick and look through this and see if you got the correct answer. If you got this first part here, the N2H8SO4, that's awesome. You did all the math correctly and you went through the process. That's great. What you need to work on is getting to the end and saying, do I have a polyatomic ion somewhere in here? NH4 is kind of hard to recognize. It's your only positive ion you're going to have at the beginning, or polyatomic ion, sorry, that you'll have at the beginning. All of your other polyatomic ions that we work with will be at the end as the anion. So remember, the first positive part is called your cation. Your negative part here, like your SO4, is called your anion. So let's do one more sample to review before we go on to molecular formulas in the next video. So here's your next one. So go ahead and press pause and complete number 3 and see what you get. All right, so for this one's pretty straightforward, pretty easy for you. One thing to remember when you're writing your formulas, make sure that you always put your metal, which is your positive or your cation, first, and then your anion or your negative second. So your SO4 is second, potassium is first. And you can also check these and see if they make sense. Potassium's a +1 charge, sulfate is a -2 charge. So you're going to need 2 potassiums for every 1 sulfate. So this empirical formula makes sense. Like, your formula should still make sense. And the one above this, scroll all over, your NH4, NH4 from page 7 of your periodic table has a +1 charge. So we need 2 of them because sulfate here from page 7 has a -2 charge. So this formula makes sense. And that's something that you need to get used to, is looking at your answers in chemistry and seeing, do these make sense? All right, so that's all for this first video, just to review empirical formula. I hope you guys have a good day. Go ahead and move on to your next video for learning how to write your molecular formulas.